Welcome to another video. This is for the 18FQ24 family, and this is about getting the new chip family working. So this one is about what I'm calling the EEPROM challenge. I mean, I'm working through a set of videos, 20 odd videos, and each video actually tests another capability. So I've got down to the timer overflow. That's all been done fine, all worked absolutely perfectly, because nothing really changes in that space. EEPROM. So now I'm down to EEPROM red. So showing values on a serial terminal, and that's the video I'm going to show. If I show you what's actually happening, I've actually loaded the demo in. I'll show it to you in a second. But if I just bring it in, you can have a quick look. This is what I'm getting, and if I reset the, how do I reset it? If I reset the chip, I'll just clear that down. The first, well, did I just erase it? What have I done here? Why is that not reset? Let me just power cycle it. It's probably because I've actually lost connection to the serial. It had 27 on it permanently. I'll show you the problem in a second. Open source compiler. Right. We know that we've had problems in the chip in certain areas. This is the way it sort of works, and we've had some chip constraints, and that was in the we have to apply those to our source code, and we've had a problem in the DAT file in the past. I suspect this one's in a library. A library needs updating as well. So I've got a board. I'll show you the board. Show you the board just to make sure we're on the same desk cam. This is the board. Here's the Q24. Serials connected to, and I'll show you that in a moment. But essentially, what I've got is a prototype board, some LEDs, some switches, pots, connections, USB, etc. It does all that, and I've got USR TTL connected, so I can see what's going to happen. So I'm trying to get the, oh, that's not right, is it? What I'm trying to do is get the EEPROM result on the terminal. That's what I'm actually, oh, I spelled it incorrectly. On a terminal, and that is not happening. So if I show you what we're doing, this is the program. It's a standard program. I don't change this at all. I just change the header. And in the header, we know all this works because it's exactly the same as all the previous videos. Hardly likely to be the setup of the chip, right? Okay. All the constants, and then in here I've got a loop, and that loop is it's supposed to write out EPWRITE some data, and then read that back in. And what it does, it waits 3 seconds after programming it and puts it on that terminal. 1, 2, 3, go. All right, what have I done wrong here? Oh, have I knocked it off? Oh, the cable's come off because I was moving things about. Look. There we go. Oh, there you go. That's certainly doing something strange. Rescan, connect. That's certainly doing something strange, isn't it? I've got that on C6. Just try to reprogram it. It's a little bit upset. Something's not happy here. I know it's I'll just disconnect, rescan, reconnect, clear. It's found the 24. It's programming it. 2, 3. Oh, finally, it did it. Disconnect. Let me zoom in on that. That was just me moving stuff about the desktop. So this is what it's supposed to do. Look, it's supposed to put some values in here, and they're structured values, so I know they're going to be 55. I know this is going to be FE, and it's essentially 255 minus the EEPROM address, the actual address. So it's writing 255, 254, 253, 2X, and I can sort of look at it and go, yeah, that looks right. And if I come into a pick git and I uncheck that. I read the chip in. Oh, it says it's not writing it. So something's not happening. Something's not right here. I mean, I obviously don't know yet myself. But look, once it gets down to here, look, it just gets stuck in some sort of loop. Look, it's getting stuck in a loop. As many places it could be. If you go back to the diagram that we had, we can rule out things quite quickly. We know the program works because it's worked in the past. This is the. Let me just put that up so you can see it on the screen. We know it's not likely to be the DAT file because we've already sorted the DAT file out with respect to the memory. I don't think it's a chip constraint like the power piece. It's something in a library. And so the way to debug this is very simple. Into the program, Shift F7, open up the assembler. The command I'm using is EPWRITE. Is that working correctly? Let's have a look at that. In my assembler, EPWRITE. Now, it says here that EPWRITE is writing out some address. And here we go. It says put the address into sys address here, sys e address, and it's a word value, so it does it twice, like the high byte and the low byte. And it says the out data, put it in a variable called EE data, and then it calls something completely, well, slightly different, NVM ADR EPWRITE. What? That's because GCBASIC does some clever mapping and it knows what type of chip it is. So it goes, oh, I need to call slightly different routine for that. So if I could Control C, Control F, and find that, it says you will find that routine in EEPROM.h at line 313. So it tells you in a few seconds what routine's been called and which file it's been called. Control R. Let me just call up the EEPROM. And here it is. It's in my low-level folder. And in reality, I already know where the problem is because I've been here before, not today, but in the past. Let's go to the top look. Look at the last few changes in here. Added support for AVR-DX, added support for Q20s. Oh, look at that lot. I wonder what that is, eh? Well, let me just do a search for Q20. So there's a load of stuff in here for the Q20 chip family. And I already know that a Q24 is the same as a Q20. So I can, and I'll just do this for you in a second. I'm just taking a copy of what I do for the Q20. Okay, now do it for the Q24. I'll come back to what I'm actually doing in there in a moment, I think. Compile. Sorry. Connect up our terminal. Clear the terminal. 1, 2, 3. Hey, it worked. So what did it do? Should we have a look? It worked. So what did I change? And what needs to be changed? It only needs to be done in the master, so I'll put this in the master in a minute. So look, it says, is the chip subfamily? So where does it get that from? Well, it gets that chip subfamily. Where does it get that from? Let's look in pick info. Pick info, where is it on the screen? Over here somewhere? Sorry about that. I'm just trying to find pick info on the screen. Here it is. Where did it get that from? We're looking for something called chip subfamily. Well, it says in here, look, subfamily is 16111. Subfamily, there it is there. And that is exposed in your scripts as chip subfamily. Hence, that's what's in here. Chip subfamily. So chip subfamily, and it's equal to that constant. Ooh. We've had this discussion in the past, have we? Not sure. Let's have a find out what that is equal to. If you open up the Explorer and open up the CDF file with respect to this chip, CDF, let me just see, you can see it on the bottom of my screen, CDF for this chip. Here it is. Control F, enter. It says this particular, so we're looking for what that equals. 161110, 161111. So a Q24 is a 16111. So these constants are fixed; they cannot be changed. Okay, so there's only, there you go. You got one entrance in there for the Q24. This is where it's used. Oh, this is exactly where it's used. And then you've got the final definition of it. So if it's 16111, it's not going to work. And so what it does, it comes through and it says, if the chip family is equal to that, which it is, then it will do some stuff. Let's look in the source. It says here, it sets the NV address to 38 plus the address that you're passing to it. So what it was doing previously, it wasn't setting the address correctly, and it was just overwriting the program. Horrible mess. Okay, so this needs to be, microchip do this in the back end of their code, so we're doing it at the front end of our code. And then it says, for this particular type of write, I need to set mvcon to 0, and I just need to set this address. And the rest of this library works. It just goes, oh, fine, I'll just work. And what I did down here for the Q24 is just copy that section down. It's the same section. You can use an OR in here, but I didn't for clarity, and I don't for clarity. So in here, I can find the other option in here, which I just added, Q24. It says in here, set the upper byte address to 38, and then set some bits for us, okay? All right. I have the Q24 is the same as the Q20, which is the same as some other chips, but I did the groundwork in the past. Like you can see a Q43 slightly different. These look like the same as the Q84s. So they work. And each chip is tested, so we should be confident. Hence we get the correct answer inside of here. So when I push my switch, my demonstration now works. Okay, so I've now got an EEPROM file in here. I'm going to come down to the comments, take a copy of that line, put a copy there of this line, save it. And so what happens next? Oh, well, let me just tell you what happens next. I go File, Save As, and I put it in what's called the build area. And the build area for this is, as you know, it's the include folder, the low level folder, and I overwrite the existing EEPROM. Now it's in here, and if you look very carefully on the screen, I'll zoom in. I don't have to zoom in. You can see that we've updated a number of files. So if I press save, it will then put that in the gold build area. And you might not believe me, but watch this. I can come into here and say right hand mouse button on that file, more options, tortoise, tell me what changed. So in here, in the back of here, I'm going to zoom out just so that you can sort of get an overview of it. You might not see it all. It shows me that I've added something here in yellow. Use that, put that back as it was. And the next change I can look at is what changed. Yeah, there's a Q24 change in there, look, and another Q24 change. When I submit that shortly, those changes will all be ready and released with the release package. So all these changes need to be put in the right place, and this one goes in a particular folder called build. That makes sense. It's the gold build essentially. And now what I can do, because I save that, I will then, I've got a copy of that on my locally. It's stored. It's all backed up. Just so you can see, there's a backup drive here. In terms of, it's identical to the other drive, and if I die, that goes to Hugh. Back into GC code. Close that. I can close the assembler now. Oh, in fact, the assembler didn't change, by the way. Did it? Oh, did the assembler change? Oh, that would be quite interesting, actually. Let me open up EEPROM again, the local copy. Control Z, I'm going to put it back as it was, and we can see what changes. Oh, that'd be quite interesting and quite a learning experience. So I've just reverted all those changes, okay? All right. In my local copy, not the master copy. If we look in here, it says for this function, it says set the upper byte of this long address to 38 hex, then move the parameter that we passed it in sys EE address into these particular registers. Then it says set the MV write it out, and then get the value back. So essentially, this is setting the address. It sets up sets up the MV command for read operations. It says go get the data, and then moves it into the variable. Because I've undone the changes, we can see what it said, why it went wrong. If I compile that function key F7, we will see. I didn't spot that before. I should have spotted that before, really. That look, MV read wasn't doing anything. It's just not doing anything. It's actually just saying, go get the low byte and return me a value. That's why it wasn't working. And all this, if you studied this very carefully, this is actually for an old, I'd imagine this is for a 16F88, something like a really old chip. So I can actually control Y all my changes, and then save that. I can then push function key F7 to reassemble it, and we can look in MV read here. Look, there we go. We can see it's actually specific to this chip family, so that all looks correct. And we can see that this is specific to this chip family. Fantastic. So things happen, magic's happened, it's all working. Into PowerPoint. What was the fault here? EPROM.h required updating. And I would imagine for every chip family, it would be the same. I'm going to put that down into my little done file. Control X. This is my done list down here. Oh no, I can leave it at the top, can't I? Because I've done it that way in the past. I can paint that as grey. Let me just paint that as grey because I've done it. Oh, I'm quite pleased by that. So, EEPROM quite update, and that is being completed. Okay, that's been done. I'm happy with that. It means I've done it. It says required as a post, as a pretty clear statement of what I've done. Okay, there we go. EEPROM works. Let's just check that out. Push that button again. Look. I'll reprogram it actually, in fact, just to make sure it all works. And it takes a few seconds, doesn't it? So this is the test program I'll be using in the demonstration tomorrow's video. Okay. Miraculously, it works, you know. You think, oh well. If I push the button, it just writes it all again. And so I can visually look at that and go, yeah, that looks fine. Okay, if I push the button, does it again, does the write and then the read, then I would verify it inside of BitKit Plus, just read the EEPROM. And in the EEPROM down here, look, whereas before there was no values in there, I will just show you. I am just verifying that visually. That looks absolutely spot on. New chip family, getting the basics operating. Enjoy.